Thank you for the introduction. Good afternoon, good evening, greetings to all in the room and also online. I hope you all are awake, and I'll try my best to make it more interesting. Yeah, definitely I'll talk about how we build a cost-effective and scalable log analytics solution at FourKites. And it's not only limited to log analytics, but our main motivation was building a log analytics solution. And I'll also cover, definitely I'll talk about how Trino is our core part of this entire solution. But I'll also talk about other components and how we build this entire solution and how we stood it up. So that would be the core of my talk. So a quick intro about me. So I am an architect at FourKites. And yeah, I love building data systems, love writing SQL. Yeah, and have worked on large scale databases or data warehouses with Amazon and Uber. And yeah, I've seen the data world for quite some time. I've seen when these one-click deployment and these solutions were never heard of, and you had to rely on your DBAs and take appointment for them to deploy your changes maybe the next week or week after. So quick intro about FourKites. So what we do, so FourKites is we help your supply chain runs faster and better. So we provide you end-to-end visibility into the supply chain solutions, whether it's your inbound or your facilities or your transportations or your orders and inventory. So we cover everything. We have among the largest network of real-time supply chain data with us. So we have integration with a lot of our partners. So we cover lot of full truckload carriers, ocean data, ocean coverage we have, rail coverage we have. On a scale, we regularly track around 3 million shipments on a daily basis. So we deal with I would say not the massive amount of data, but a sufficient amount of data, and integrations is our core strength. Now, coming to the motivation, right? So we have approximately, we have a distributed microservice-based architecture. We have a lot of services and workers together, approximately 110, 120 plus microservices and workers, which we have in total. And our applications love producing logs, and that is unfortunately sad, but that is true. So on a regular basis, on a daily basis, we produce anywhere between 6 terabytes, 7 terabytes to 8 terabytes of logs, and we keep on adding more services, and the more logs get produced. So now, at least for new services, we are controlling, but there are legacy services, and we have an ecosystem now which is very dependent on logs, right, for our troubleshooting, for our operations team. So you must be wondering why so much fuss about logs, right? But these logs are very important for our, some of our engineers, some of our operations team. And they demand the retention of these logs for a very large period. They want us to retain these logs for 120, even 150 or half a year, right? Now, the reason for that is that when they work on issues, right, sometimes there are lower priority tickets which are created by our customers. And when we work on them, it has been it could be 2 months or 3 months at times when the ticket which was created is being addressed. And then to understand what has happened at that point of time in the system, right, in the history, the only way to understand is with the help of the logs. So these logs are important for us. Now we have been using third-party solutions like Log Entries and New Relic, and they're excellent. They are really amazing solutions out there. But I think for us, the problem was that there were two major problems which we are running into. One was that every time we had this retention problem, the more logs we produce, we have to always run to our applications to reduce the logs. We have to keep on repeating these iterations where we are saying that, okay, let's limit the amount of logs which we are producing. Second is that what we also found is that our teams were querying these logs, and then they used to compare it with the source of truth, right, which is our our transactional systems or our data warehouses at times, and they would compare. So it was too much of going from one application to other. So they'll go into these log aggregators, they will search the logs, they will find out the data, and then they'll again go to the different systems. So it was also not that efficient. So we thought that how can we improve this? Yeah. So I think the approach which we took was definitely our main theme was that how can we keep the cost in control. Also, at the same time, build a system where we can give the capabilities to our users to integrate these log data sets with the other data sets which we have, or whatever troubleshooting they are doing, right? So that is one of the motivation for us. And then again, we wanted to avoid get into this continuous battle of how much data we want to retain for a particular application. Can we make it not endless, but at least 90 to 120 days, which is demand by the business. And then reduce this dependency on third party if possible, because every time we end up into renewal cycle, right, you know that there are many surprises which comes into the way these agreements are formed. So I think these were the main things. So the solution we came up was SPOG, which is single pane of glass. So it was not only our log analytics solution, but it was a lot more than that. It is a super tool which allows you to definitely search your logs, and also you can bring in your own data. So you can bring the data into S3 and then use the system to kind of query that data. At the same time, we also had connections to our data warehouses and our other databases, and then you can use this logs along with these systems and collectively do a more efficient search across the systems. Apart from this, we also provided a user interface to the system where we are using Apache Superset, so that allows us to create dashboards and alerts for different patterns of logs and other things, right? So they were it's a complete ecosystem which we had built over there. So coming to the architecture, so the architectures-wise, we had some critical components into the system. One is for our data ingestion. So we use FluentBit to ingest the data. For specifically talking about the logs here. Now we are on multi-cloud, right? So we run our solution on AWS as well as Azure. And in AWS, we have some legacy applications which run using Elastic Beanstalk, and we have some applications which are running on AWS Kubernetes. And then we have all application in Azure runs on Azure Kubernetes solutions. So we have FluentBit agents deployed along with these applications into these clusters. Then we use Lambda for transformation. I'll cover that, what is the transformation that we do in Lambda. We use S3 as our object store, as a storage layer in Parquet format. And Trino is the heart where we use it as a distributed query engine for us. Superset is the is our tool which we use for providing the end user access to this data via the Trino. And Jenkins is used for our deployment. So a little more deep dive into our architecture. So you can see that we have these FluentBit agents which are continuously getting the console output of these from these applications, and then they are shipping the logs to S3. So what we have done is in FluentBit, when we take these logs, right? So we have two main settings which we are working with. One is the the time limit setting, where some applications will push the logs every 2 minutes, some applications would push the logs every 5 minutes. And then we also have a file size setting, because file size is very important for us because we use Lambda as the transformation engine. So we have narrowed down on a 5 MB to somewhere between 5 to 10 MB size for different applications. And what happens is that either one of the limit would be crossed. So either the application is producing too much logs, so it will start sending us logs maybe within every second or every 5 seconds based on the number of instances it is running. And then other parameter would be that the time limit has reached and they will ship the logs. So they upload the logs, raw logs, FluentBit agents upload the raw logs to our S3 layer. And from S3, on object creation, we trigger a Lambda. So what the job of this Lambda is that the log is so we have different applications which run in different languages. So we support Python, Ruby, Java, and Golang. So each one of them have their own way of presenting the logs to us. And when these logs comes to S3, we transform them into a standard format, and we extract the key elements out of it to help Trino do a faster search. So that is the job of Lambda. So it triggers on every file, it processes that file, and then produce a final output, which is again stored back into the S3. And that is then connected to Trino via the table. And Then Trino also talks to our data warehouses and other application databases. And then finally, we have Superset, which is used to serve the UX layer, right? So that's how our entire architecture works. A little bit more deep dive into Lambda. So you can see that this is like a sample log row which I have put over here. So you can see there are like some interesting elements in this log, right? Along with the timestamp, we have our thread ID or the chain ID, which links the entire request from start to the end, and then across the distributed applications. And then we have like different message types, the internal keys which we have for our tenants, for our shipments, tracking ID is what we call it. And there are different flags. So what we do is we transform this data into this tabular format. Like you can see that we extract these columns. And the main challenge is like doing this extraction. So we have to rely a lot on regex based patterns, because if you're seeing this, right, so this row is like saying it as message type, whereas other other application which is producing a similar log, they might say it MSG type. And instead of tracking ID, it could be track ID, or it could be something. So it's like there are huge permutations and combinations which our teams have discovered, and they have utilized them. So we are working on like standardizing our logging patterns, but yeah, as of now, this is the truth what we deal with. So yeah, so once we have built the system and we were ready and we went live, so the requirement was that if you go live, right, so you can't wait for another 120 days. So you have to backfill the previous data also, which was there in other tools, right? So I think that was the challenge when we were doing this migration. So when we did this migration, like we had log entries already live, which was running like for some years with us. So what one of the benefit with log entries was that it was doing a daily export of logs to S3 for us already. That was configured. So we had historical logs available to us. So that was a big benefit to us in doing our backfill. So how we did the migration was with a dual, right? So we were ingesting the logs into log entries. We were ingesting the logs, real-time logs into our SPOG system or SPOC system. And then we also had this backfill part, right? Where in the same S3, like in the S3, we had this dump of logs which is available to us. And we did a ETL process of those logs across applications. And these were huge data sets, right? These are like, you can think of these are 90 days of logs which we have accumulated. So we converted that into the same format, like how we were extracting the data from Lambda. We use a similar logic and again push it back. So that's how we kind of finally migrated from these systems into our internal system. And the user was having the capability to kind of talk to both the systems in parallel, and they were able to kind of give a sign off to us. So yeah, some important configurations which we did with Trino. So like one was like the table. So we wanted to keep it like very simple for our users so they don't get too much confused with which table to use and like where to go. So we kept it like a simple one table solution with partitions deciding which like application logs they can search for. So we had like a partition strategy where we had the source was our like which cluster was sending us the data. And I would say not even cluster, it is like at the environment level, whether it's a AWS EKS or Azure EKS or EBS. And then we had the date-wise partitioning and then the application level partitioning. For partitioning refresh, we were using like a register partition function and sync partition metadata function. And we had Airflow pipeline, which will keep on running and then looking for these new folders and then register those partitions. So this is like a snapshot of our S3 folder structure. So you can see that inside a date, we have different applications, app level folders. And inside the application you can see that we have the final Parquet files which were produced by the Lambda transformer. So another interesting use case was that we had to implement the row-level security. Now, it might sound surprising that security on the logs, but yes, logs, like for us, the logs contain a lot of data, which is sensitive also because teams do write everything into the logs, right? That they have received this request, they have received this payload from this customer. And it's for our internal users, we have complete access. There is like no filtering done. But we also had some partners who work for us, and they are responsible for onboarding and managing some customers into our platform. So for them, it was required that we like give them access to logs, but only to those customers which they are responsible for. So for that purpose, we ended up having we added a new column into our transformation layer where we search for some patterns into the logs and say that, okay, can this row be seen by the partners or not? So that's how we implemented. So we ended up having a view on top of the base log table, and that view was exposed to the our partners channel. And again, to do that, we also have to use the authorization. So we used config file based authorization where we controlled different users were created in Trino, and each user, there were different applications users, there were different normal read-only users, and there were partner users. So each one of them had different access on different tables and our schemas which we have created. So some of them were having the ownership access on the schema which they were owning, where they could create and objects inside it, and then there was some common access which we had given to read-only for the common tables which we had. Our user authentication was referencing the HTTP server authentication password strategy, which has been documented in Trino website. So we have used that to kind of do our authentication. Now I'll talk about some optimizations which we did. So I think there is, I think we all understand that we need little large size machines to run Trino better. So we ended up using R5 2x large machines on Amazon. I think one of the challenge which we faced a lot today was the log file size, right? Because since we use Lambda and then we were getting the logs at a very fast rate, so the number of files is huge. So we end up moving around anywhere close to 1 million files on a daily basis. So, and querying them is everyone understands that it's a challenge, right, with Trino to kind of query such a large number of small files. So we wrote a compaction job which will compact, let's say, D-1 days of log into large size files and give us a better performance. So yeah, so if majority of our cases, we've realized that users are more interested into the historical or past days of log, so the performance was acceptable. Yeah, if they query something on current day's log, then also I think it works. But yeah, the performance differences are substantial. So, but yeah, so that's what we did. We ended up having a compaction job to rescue. Then I think another thing which has been discussed in the morning session also, that how do you prevent a user from writing a bad SQL, right? So for us, the challenge is the same, that we cannot prevent. So what we ended up doing was these timeout settings that, okay, we initially had 15 minutes, but then some users complained that, no, we had actual write query, but it was taking time, so you have to increase it. So we ended up relaxing it to 35. I think right now it is 35 or 40 minutes, which we do, and then the query times out. So that's what we ended up doing. Another interesting thing what we did was that we ended up creating a lot of subsets of log sets. So there were some key log sets which we had in our ecosystem or in our applications, and majority of the searches goes to them. So depending on some of the use cases which were common, we kind of enhanced and created some subsets out of these to help queries run faster. Now I'll talk about some optimizations we did for the Lambda layer or the transformer layer. So I think as you would understand that Lambda gets built based on two important parameters. One is the memory which you provide and the duration it runs. So what we found was that since we are doing a very high number of invocation of the Lambda, so we found that initially when we launched, right, there were a lot of timeouts which were happening, and we were not noticing them because the scale is so big, right, that maybe some logs are missing, we don't immediately understand, and we don't immediately find it, right? So now we have a very robust monitoring that we even trigger a single failure of Lambda, but when we launched, we were not ready for that. So what we found is that when we looked and debugged more, we found that you have these searches available in the Lambda that you can find out which are my high let's say, build invocation queries and which are my timeouts. So the challenge with timeouts is that they run for the entire duration of the Lambda and you don't get any output. And you're just paying for that entire thing. So we tune that. I think we reduce the file size and we optimize the Lambda processing also. Another important thing which we figured was that as we were getting the entire log rows, right? So we were extracting all the columns, assuming that they will be searched. So we ended up like having approximately 70 odd columns in the table. And that was done for every file, right? Because the Lambda was like, it was running for every file, the same process was running. So then we analyzed and we found that they were like, every application has different needs, but there was some common set of columns which was required for every application. So then we narrowed that, okay, for our Lambda, these are the mandatory parsing rules which will be there for every application, and then there would be optional rules. So that reduced our max timings of the Lambda by a significant portion. Now coming to our data store optimization. So we use S3 and S3 is like a low cost, but at this at large scales, I think and the retention also, I think it becomes a costly affair. So we if you remember the architecture, right? We had the raw layer and then we have the transform layer. So when we launched, we were supporting both the layers for a longer duration. Like we were retaining the data in both the layers because of the fear that we might have to replay the logs and transform them again. So how do we do that? So after going live and seeing the system for some time, we were confident that we never had that situation. And even if we had, it would be within maybe 1 day before or like that. So we never had that catastrophic failure where we have to replay entire 1 month of logs, right? So for that reason, we looked back at the optimizations and we removed the retention for the raw layer to a bare minimum. I think 5 days it is right now, and that reduced our substantial cost substantially. So that helped us doing, and then we set up archival and lifecycle policies for S3 to help us do this. Yeah, and for UI, we use Apache Superset. Now Apache Superset, if you understand, it works on a sync mode by default, and it blocks, it uses the same thread, and it adds up more worker to scale your workloads. So this was one of the challenge which we faced. So we converted into a async mode because our queries are not microsecond response queries, right? They take some time and then they give. So so we converted it to a async mode. Now in async mode, what happens? It uses a Redis cache where the results are pulled from, let's say, Trino query. It populates into the Redis cache, and then Superset just queries that Redis cache to give the response. So it's not blocking that thread to the database. So that's the improvement which we did on the UI side to make make it more sufficient to talk to the Trino. Yeah, so this is a quick, I cannot give a live demo, but yeah, this is a screenshot where I think it is visible, it should be visible, that you have this table and you are filtering on the partitions and then you can see. So this is the main interface for the users. Apart from this, you have the dashboards and alerts which we have set up. And this is our table structure. Yeah, so these are the metrics. We support around 350 applications today. And we ingest 1 million files, and we scan approximately terabytes of data. Now, yeah, so these are the success for us. So we are able to run this solution at significant lower cost than the third-party solutions. Yeah, definitely we are not able to provide all the solutions and the latency expectations. But yeah, I think this works for us. And we are currently providing 120 days of data retention. Our onboarding is very easy. So the moment our application is deployed and is ready, we start shipping the logs to the system. And another important point is that we can now unify the data from different systems with the logs and the other systems which we have. Yeah, lastly, I think the lessons learned is definitely the cost of storage is very important. So that is definitely a big thing. And yeah, if you can standardize the log format across all your applications, it will help. And reducing of logs should happen at the application level. It is not that efficient to do it at the the drop filter level where you're just turning off some of the logs when you are ingesting. Better to reduce them at the application level. And yeah, be careful with the Lambda, because Lambda cost and the timeouts are like two very, very unfriendly things that if you have timeout, the Lambda cost will skyrocket. Yeah, so lastly, next steps for us is we are looking again at intelligent tiering of S3 to see if we can get some cost benefits. Secondly, we are also want to look at Glacier. Now, we know with Glacier the challenge is that if you have too many objects to push and then to retrieve them back, then the benefit which you get in the storage goes away. So we are very little careful, but we are exploring that. And we are trying to improve our auditing and monitoring of the system a lot so that we can be more careful about what is coming into the system and optimize the cost optimization opportunities, right? Because it's a system which is built to sustain at a lower cost, right? Or maybe reduce the cost further. So that's our key things. And yeah, definitely the learnings which I had with this conference, I'll take them back and try to incorporate them. Yeah, that's it from my side. Thank you all.
Awesome. Thank you so much for sharing those insights around logging and stuff like that. There might be questions online. It's also interesting to note that one of your next needs and like desires you want to find out more about is monitoring, which is going to be the topic of our next talk. So that works very well for us. So let's see what questions there are.
Yeah, I was curious about your ingestion with Lambda. It seems like you're supporting a lot of like T- and long tail analytics. Is there a reason for using like SQS and Lambda to ingest so rapidly? Do you have a need to be able to immediately query something in Trino as it lands?
Yes, yes. So the question is that why do we ingest so fast and use Lambda? Yeah, so that is true. I think, so we have, like sometimes what happens that we have some use cases where a user is resetting his password, and that password, they want to check in the logs that why he's not getting the SMS, whether it's a failure from our third-party provider who is supposed to send that SMS to it, right? So then they go and search into the logs immediately. So that's the reason. So we like to, so there are different patterns. Sometimes the alerts, they want to configure that within 5 seconds, like within immediate 5 seconds or 10 seconds, if I have this kind of a pattern, just send it. So that's the reason we have to ingest that.
Cool. Any other questions? I do have a question. Given that you are like logging or like processing logs from so many different applications, do you have any struggles in terms of all the different logging formats, like including like even like logging to JSON and like just like single line and that kind of stuff? Is there some like interesting lessons you learned maybe?
Yeah, so yeah, as I said that if we can standardize the logs, it is very easy for us. Otherwise, it's super challenging. And honestly, to speak that some of our legacy applications, they don't even have a proper JSON format. They have their own version of a JSON, which might be like not using the proper delimiter. So that's why we have to rely on regex. And then the naming conventions are very, very different. So it could be shipment ID versus ship_ID versus, let's say, S_ID, right? So we have to find out all these patterns as we build this solution, and then we have to incorporate them in our transformer. So it's very, yeah, so you have a very good question. It's very difficult for us, but we have to live with what we have.
Yeah, well, all these different applications, everyone wants to reinvent the wheel, do something else differently, right? So.